Chapter 5, Question number 1. Collingwood Contractors is a new home builder. They build several different tiers of houses. They have 3 levels, which represent increasing levels of luxury. So you can build tier 1, tier 2, or tier 3 types of houses. Tier 1 houses are $110 per square foot. Tier 2 is $180 per square foot, and Tier 3 is $235 per square foot. They also have 3 different equipment options. Option 1 is Ruby, which costs $18,000, Sapphire, which is $27,000, and Emerald, which is $36,000. It tells us that there is a cost for utilities if required. Those costs depend on the region of the country and whether the lot is located in a city or a suburb. So if you're building a house in a city, usually there's going to be utilities already available. And if you're building it in the country, you might have to create your own utility infrastructure. Also, if the building is in a city, there's a premium for the building equipment and costs, and that premium is 15%. So we're going to work on Part A. The customer has expressed an interest in a Tier 3 4,500 square foot home. It's going to be in the city, and they want Sapphire level equipment. So how much is that going to cost? So we have the table down here at the bottom. Design costs, the chart tells us, is $35,000. And that's the same price whether the building is a Tier 1, 2, or 3. It's just a flat $35,000 fee. The next part is building costs. The customer wants to build a 4,500 square foot home, and they want Tier 3, which the question tells us is $235 per square foot. So we're going to do $235 per square foot times 4,500 square feet. And that gives us $1,057,500. Equipment costs, for Part A, they want Sapphire level equipment, and so that's going to be $27,000. City premium, in this case the city premium applies because they're building the house in the city, and so that'll be 15%. And it tells us that it's applied to building and equipment costs. So building costs that we calculated is $1,057,500, and equipment cost is $27,000. So that's a total of $1,084,500. Then we multiply that by 15% or 0.15. So that gives us a premium of $162,675. And for utilities, it tells us that the building site is in the city and no additional utilities access is required. So utilities cost would be 0. So the total estimated cost for this house would be $1,282,175. For Part B, I'll let you do that on your own. It's a different tier, a different level of equipment. It does require utilities access, and it's built in the country, so that means that there's no city premium. And the square foot design is for a 2,200 square foot house. So plug in those numbers and see what you get. Question 2. Hemlock Nutritional Supplements has the following costs for the most recent month. Direct materials is $126,000, direct labor is $105,000, and variable overhead is $92,400. And that was for 60,000 units or cases. Fixed manufacturing overhead was $144,000. Now they expect costs to rise for the coming year. It says that direct materials is going to go up by 30%, excluding any effect of volume changes. So we'll look to see how to do that. Direct labor goes up by 6%. Fixed overhead goes up by 13.5%, and variable overhead per unit is going to stay the same. And so we have to prepare a cost estimate for 48,000 units. So let's use Excel for this one. Our costs are direct materials, direct labor, variable overhead, and fixed overhead. And so that'll give us total costs. Last month's costs were given to us $126,000 for direct materials, $105,000 for direct labor, $92,400 for variable overhead, and $144,000 for fixed overhead. So last month's cost was a total of $467,400. In the next column, we're going to put the percentage of increase, and we're going to do it with a formula 1 plus the cost increase. So remember, multiplying something by 100% is the same thing as multiplying it by 1. So for direct materials, if it's going up by 30%, if we want to find the new total, we're going to multiply by 130%. For direct labor, it's going up by 6%, so we're going to multiply by 106. Variable overhead, that's staying the same, and fixed overhead is going up by 13.5%, which will be 113.5%. And so for the upcoming month, we're going to do equals the last month's cost times the 1 plus cost increase to get the new totals. So direct materials cost plus 30% is going to be 163.8. Then we click the bottom right corner and drag down to copy our formulas. And so here are our new totals. But we also have to consider the change in volume. So these were the costs if we produce 60,000 units. We're only going to produce 48,000. So we're going to do equal sign 48,000 divided by 60,000. That's 0.8, or percentage-wise, that's 80%. So if the prior month is 60,000 units, which we consider 100%, then the next month is only 80% of that figure. And that's going to be 80% across the board. Now remember, fixed overhead doesn't change based on volume. So for this one, I'll just put NA. And so for the upcoming month's cost at 48,000 units would be the 0.8 times the cost that we figured in column D. That would be 131,040 for materials, labor is 89,040, and variable overhead is 73,920. Now remember, for fixed overhead, that amount is fixed, so we're just going to use the same amount that we had in column D, which is 163,440. So our total is going to be 457,440. So that's our answer for part A. For part B, they want us to determine the cost per unit for the recent month and the upcoming month. And so we just have to break down these totals into a per unit cost. For the recent month, cost per unit, that's just going to be this 467.4 divided by 60,000 units. We get $7.79 per unit. And for the upcoming month, that's going to be this figure, 457,440, and divide that by the 48,000 units we're going to sell in the upcoming month. That gives us $9.53 per unit. So glancing at these figures, they seem to make sense. The upcoming month is going to be higher, and the fact pattern did tell us that the costs are going to go up by 30% for direct materials, 6% for labor, and 13.5% for fixed manufacturing overhead. So 3 out of the 4 costs went up, and so it makes sense that the cost per unit went up accordingly. For question 3, I'm going to let you do it on your own since it's very similar to question 2. But one thing to notice is that they use different terms. So instead of saying direct materials, they use supplies. Instead of saying direct labor, they use employee costs. Now for total administration, that's an overhead charge, and it gives you the total of $455. It doesn't break it down into variable overhead and fixed overhead like the previous question, but it does tell us that out of this $455, the fixed portion of it is $245. So you should be able to work backwards and figure out what the variable portion was. And then you can use the same spreadsheet that we used earlier. Just delete the numbers and plug in the new ones and adjust the calculations accordingly. So you should be able to get question 3 pretty easily. Question number 4. This deals with the high-low method of estimating costs. Kirby Fasteners supplies the electronics industry with accessories for cases and disc enclosures. And so it gives us the costs for the past 6 months. Part A says to use the high-low method to estimate the monthly fixed cost of production and the variable cost of production per unit. And then Kirby says that they are forecasting 11,400 units in July, and based on what we calculate in Part A, we have to estimate production costs for July. So remember, for the high-low method, variable cost equals the cost at the highest activity minus the cost at the lowest activity. You divide that by the highest activity minus the lowest activity. So looking at the facts given to us, looks like 13,200 is the highest number of fasteners built in a month. So that'll be our highest activity. And our lowest activity is going to be the second month, 9,340 units. So those are the two that we're looking at, 13,200 in this month and 9,340 in this month. So that means variable cost is 228,080 minus 180,795. We're going to divide that by the number of units for the highest and lowest months, 13,200 units minus 9,340 units. And so if we crunch those numbers, we get $47,285 divided by 13,200 units minus 9,340 units, which is 3,860 units. So that gives us $12.25 per unit. And now we can use the formula total costs equals variable costs plus fixed costs to figure out what fixed costs are. So now that we know the variable cost per unit, we can pick any of the months on the chart and plug in that figure. So let's pick the high month, 13,200, and the cost is $228,080. So using our formula, the total costs is 228,080. Variable costs is 1225 times 13,200 units at that level plus fixed costs. So to further our formula, it's 228,080 equals 1225 times 13,200 is $161,700. And that's our variable costs plus our fixed costs. So if we do 228,080 minus 161,700, we get that fixed cost equals 66,380. For part B, it says that we're estimating 11,400 units in July. So what would our estimated production costs be? So we would use the same formula here. Total costs equals variable cost plus fixed cost. So we would do 1225, which is the variable cost per unit. Multiply that by 11,400. And then we would add that to the fixed costs, which we calculated in part A, which is 66,380. That gives us total costs 206,030. So that's part B. Question 5 is very similar to question 4. It also deals with the high-low method, so I'll let you do question 5 on your own. Question 6 deals with the learning curve. As a business creates more and more of the same product, it can usually learn certain efficiencies and create the next product faster than the prior product. Up to a certain extent, of course, but especially in the beginning, there's going to be an increase in efficiency. In this question, this technology company creates spacecraft instruments, and the fact pattern tells us the number of hours to create the first, second, and fourth units, and now we have to calculate the labor time to produce the 8th and the 16th units. So what we need to do is figure out what the rate of learning is. And all we need to do is divide the number of hours for a certain number of units produced divided by the previous level. So for the second unit produced, that took 4,500 hours. And we divide that by the first unit produced, which took 5,000 hours. So that's a 90% learning rate. And we can double check our work by using levels 3 and 2. So the fourth unit produced took 4,050 hours, and we divide that by the prior level, which is unit 2, and that took 4,500 hours. And so 4050 divided by 4,500 is also 90%. And so what that means is to calculate the next unit, we just have to multiply the prior number of hours by 90% to get the next level. So 5,000 units times 90%, or 0.9, equals 4,500 hours. 4,500 hours times 0.9 equals 4050. 4050 times 0.9 will give us the next level at 3645. So that's our answer to part A. And then the level after that is 3645 times 0.9, which would be 3280.5. So part A is 3645 and 3280.5. Part B says assume that the labor time cost $140 per hour. Compare the cost of producing the first unit to the cost of producing the 16th unit. And what is that percentage? So we know that the cost of the first unit produced is going to be 5,000 hours times $140 per hour. And that equals $700,000. The 16th unit, as we calculated in part A, takes 3,280.5 hours. We multiply that by 140, and we get 459,270. And so what is the percentage of the cost of the 16th unit to the cost of the first? We do 459,270 divided by 700,000, and that gives us 0.6561, and to And to put it percentage-wise, that would be 65.61%. The question tells us to round to 2 decimal places. So it would be 65.61%. Question 7 is very similar to question 6, so I'll let you do question 7 on your own. So that's the end of the Chapter 5 homework. If you have any questions, please reach out. Thanks.